In this video, we will talk about the new Shahed-238 drone. We will cover its development history and the purpose behind it. We will analyze its technical features, including speed, range, and engine. Finally, we will discuss its operational use, production, and estimated cost. The Shahed-238 drone is a new member of Iran's UAVs. It was first publicly unveiled in the year 2023. The main purpose was to increase speed and penetration. Its design was based on operational experience with Shahed-136. This drone is powered by a small jet engine Tolu-10. Tolu-10 is an indigenized version of PBS TJ100 engine. Using this engine increased the cruising speed of Shahed-238. The fuel chosen is standard aviation Jet A for convenience. The maximum cruising speed is around 500 kilometers per hour. In dive mode, its speed reaches 600 or even 800. Such speed makes interception by air defense far more difficult. This advantage is central compared to earlier propeller-driven designs. The reported ceiling for Shahed-238 is about 30,000 feet. This altitude enables overflying many traditional defensive systems below. Its endurance is estimated to be around 2 hours. That means it can cover routes exceeding 1,000 kilometers. The body of Shahed-238 is stretched with delta wings. This aerodynamic design improves stability and control during higher speed. A V-shaped tail was installed to enhance maneuvering accuracy. 8 control flaps guarantee overall balance and flight reliability. The takeoff weight is estimated at around 380. Most of the mass comes from engine and fuel compartment. The warhead payload is usually about 50 kilograms, though some reports mention larger capacity in certain tested versions. The launching method generally uses a solid booster rocket system. This booster provides initial thrust for safe drone takeoff. After separation, the jet engine continues forward propulsion continuously. Multi-launchers similar to Shahed-136 can also be used. 3 main variants of Shahed-238 were developed by Iran. The first with satellite and inertial guidance for fixed targets. The second has thermal and optical camera for moving targets. The third is anti-radar, homing against hostile radar emissions. The optical version can identify and lock directly onto targets. This capability allows striking vehicles or other mobile assets. The anti-radar version hunts air defense and radar systems. This expands Iran's suppression of enemy air defense capacity. Black paint coating on displayed samples drew strong attention. This dark color helps reduce radar reflection during night. It also facilitates operations in low light and nocturnal conditions. Composite body structure decreases probability of radar detection significantly. Development of Shahed-238 responded to need for higher speed. The earlier Shahed-136 had slower speed around 180. Against modern defenses, that lower speed was serious vulnerability. Thus, adding jet propulsion became the Iranian designer's solution. Official unveiling occurred during an aerospace exhibition by IRGC. Video footage showed its impact against a ground target. This demonstration highlighted technological progress in Iranian drone industry. Yet production volume information still remains undisclosed officially. Western sources reported limited production had already started. New serial numbers confirm this fact in recovered wreckage. Ukraine was the first to down this type drone. This incident was reported during the year 2024. In summer 2025, Russia deployed it operationally. Night attacks on Kiev involved several Shahed-238 drones. Combined with hundreds of propeller drones, they overwhelmed defenses. Ukrainian officials described interception as extremely challenging. Iran has not confirmed foreign battlefield use directly, but it has widely tested them during domestic exercises. The main goal was to showcase penetration capabilities effectively. These trials helped refine design and fix operational issues. Shahed Aviation Industries is recognized as the project's main designer. The HESA company cooperated in body and manufacturing stages. Tolu-10 engine was produced by domestic knowledge-based firms. Certain electronic components were sourced from foreign supply channels. Sanctions forced Iran into complex indirect supply chains. Analysis of wreckage revealed presence of Western-made components. This issue sparked debates on sanction circumvention methods. Meanwhile, Iran emphasized continued localization efforts officially. Estimated price for family drones is $20,000 to $50,000. With jet engine, Shahed-238's cost is slightly higher. Exact official figures were never publicly announced by Iran. Still, it remains cheaper than Western cruise missile systems. Low cost provides advantage of mass production capability. This strategy imposes pressure on adversary defensive networks. Because cost of interceptors far exceeds cost of drones, this cost ratio is a strategic advantage indeed. Technically, Shahed-238 is more advanced than Shahed-136 overall. Higher speed, better maneuverability, and diverse missions were achieved. Yet high fuel consumption limits its effective operational range. This limitation is its main weakness in service. The V-tail and flaps were essential for flight stability, because high speeds could threaten drones' aerodynamic balance. These control surfaces allow precise handling in long missions. Designers perfected them through repeated testing over months. In Ukraine's battlefield, Shahed-238 gained actual combat experience. This revealed both real strengths and noticeable weaknesses. High penetration ability and speed were praised as advantage, but jet heat signature made targeting easier for missiles. Air defenses in Ukraine faced tough challenge against them, although several drones were intercepted with defensive missiles. Saturation attacks prevented interception of all incoming drones. This Russian tactic aimed at exhausting Ukrainian defense resources. Shahed-238 represents a step forward in Iranian drone evolution. Iran now fields both propeller and jet-powered suicide drones. This combination provides diverse capabilities for future conflicts. Other nations watch this development with considerable concern. In conclusion, Shahed-238 marked a leap in Iranian technology. Its speed, new design, and versatile missions make it important. Mass production and combat experience will determine its future. It already holds a key role in Iranian strategy.